Today on Cloud Slaw, we're going to learn about the magic of security groups. Way back when I started on AWS, and this is before IAM or VPCs were available, I encountered a feature that fundamentally changed how I thought about cloud security and the possibilities for network security. The title gives it all away. We're talking about security groups. To understand why they're so cool and powerful, I need to cover some really quick firewall basics. The job of a firewall, it's pretty simple. Filter network traffic based on rules. Why? Because we all have lots of things running on our systems and they have been under constant attack since the very first cave person opened up one of those AOL CDs that kept falling out of the trees. Firewalls help protect us from network attacks, and mostly we put them between us and the internet, but sometimes we put them inside our networks to protect against the blast radius of an internal compromise. Now, outside of cloud, and these still work in cloud, we have two main kinds of firewalls. Network firewalls are dedicated hardware or virtual machines that are placed on the network and we route the traffic through them. Host based firewalls are software running on a system. If you're on Mac, Windows, or even most flavors of Linux, you're probably running a host firewall by default right now. Here's a quick overview of how they work, and let's go to the magic whiteboard. With a physical or appliance based firewall, we'll typically route the traffic to a subnet through the firewall for filtering. This allows or denies traffic hitting the subnet based on rules. Now, it doesn't filter any of the traffic inside the subnet, it's only going to filter traffic from the outside running to the inside. Remember, in a physical network, there's actual wires running in between, say, the firewall and the switch that's doing all of the routing on the subnet. And so we're limited by where we can put these physically or even virtually on our networks. Now, yeah, modern systems have a lot more to them, but this is still largely how people deploy things. A host firewall runs on the system itself and it's software. It's often built in operating systems, so you can run third party software. I'm currently running two different ones on my Mac, the built in one in the operating system and a more robust one as a background application. Modern firewalls, often called next generation firewalls or NGFWs, even though they've been around for like 15 years, they do a lot more than basic connection filtering, and they can capture and analyze all the traffic and look for different attack patterns. But here's the limitations. Network firewalls require all traffic to be routed through them, and due to the cost and complexity, are usually only put in strategic locations. They're rarely configured to filter point to point traffic within a subnet, and they can only do that if all the wires route through them directly. Host firewalls are more granular and protect individual systems, but that makes them harder to manage at scale. And there's all sorts of different kinds of host firewall software. And if the attacker does find a way in, they can just turn them off. Firewalls use rules to decide what traffic to allow or block, and these are usually what we call five tuples, and that word just means there's five fields to the rule. Here's one, let's go down to the whiteboard, that will block SSH traffic to a subnet. And so as I scroll down here, you can see that this particular rule, I have all of the tuples. So I have the destination, where's that traffic going? And you notice it's at /24, so it's entire subnet. The source is the internet itself. And then we have the protocol is TCP and the port is on 22 and the action is deny. And this is very typically what a firewall rule will look like. Maybe not the more advanced things that some of the NGFWs do, but if you log into one of those, like I did just the other day, you're still going to see that it supports rules like this one. So let's switch gears and talk about the magic of security groups. And security groups are different in every provider. So I'm going to focus mostly on how they work in AWS. Google is pretty close. Azure is the outlier. They have a different way of doing things. A security group is basically a container for rules. Think about it more as a policy than a physical box or a virtual appliance on a network. Security groups deny all traffic by default, and they only support rules to allow traffic. And the rule includes three items, not the five. Remember, we don't have to have the action, the allow or deny. We just need to know what is the source, what is the protocol, and what is the port built into the rule. And they always deny, and anything not in an allow rule is going to be blocked. Weird thing is within AWS, and we'll talk about how to get or deal with this, is you can't actually build a specific deny rule. Like you can't block a single IP address. It's only allows you to create allow rules. We apply security groups to the resources themselves, technically the network interface in the resource when there is one. And we build a security group and then we run an instance and tell it to use the security group. The rules are enforced at the individual resource level. It's kind of more like a policy about what network traffic is allowed or denied that you apply to a resource. And all resources on a VPC, on those virtual networks inside of AWS, have to have a security group. Cool thing is security groups can also reference other security groups. So instead of putting something in like 10.0.3.0/24 in the rule to allow access from that subnet, you can just put in SG123456 and anything that has that security group, the 1, 2, 3, 4, 5, 6 security group attached to it, that will be referenced and that's going to be what's allowed in the rules. And we're going to be able to build one of those and you'll get to see what it looks like. Now, security group rules aren't hardware or software that a attacker can target. They're just rules in the fabric or the VPC. And let's show you some of the cool things that actually make these special by going back down over to the whiteboard. So a security group that only allows traffic from the outside, and that's the example we have here. So I have one rule for the security group. Now these, you'll notice they all have the same ID, which means that is the same security group. And that security group has one rule that's associated with it. And it's 22, whoops, port 22 is allowed from the source of 123.4.5.6. I guess somebody probably has that IP address in the world. Okay, so the real structure of the rule is I kind of shortcutted there. Let's say that the source is 123.4.5.6/32, and that is mapping to TCP. And let's slide over a little bit, port 22, and that's it. That's all you need in that security group rule. Now, let's look at the implications of this by switching back over to the diagram here. If you think about it, so if I have the resource up here that has that 123 address, and it wants to talk to any of these things, as long as that's on port 22, that will be allowed. But if this tries to talk to this, even though they're on the same subnet, that is going to be denied because the rule doesn't say that other things on that same in that same security group are allowed to talk to each other. It denies all traffic except that one allow rule. And this is amazing because this means that a VPC is a default deny network. Most networks allow all traffic unless you put in a firewall or something in place. And the hackers get into, or attackers, I don't like to use the word hackers, they get into one part of the network and then they spread everywhere else. And this is where we come up with that term of blast radius, like how far can they go? And in a basic network, the blast radius is anything that after that attacker gets on that big flat network. But on VPC, all traffic is blocked except what's allowed by the route table and the security group. And this really tightens up the blast radius unless you're kind of silly and open it up. Believe me, I've seen people do a lot of that, and we'll get through some of those reasons when we get into some more advanced networking. This is my favorite part, and I've written this into Cloud Security Alliance training for like the past 10 years. A security group combines the manageability of a network firewall with the granularity of a host firewall. Think about my diagram. Those boxes run every single resources, and the rules apply on an individual resource basis for everything that security group applies to. But if I make a change to that security group, it instantly changes the rules on all of those resources. It is more manageable than a host firewall because I don't have to deal with any software stacks. I don't have to log into anything. I don't have to deal with the fact that there's going to be different kinds of host firewalls. Also, it allows or denies the traffic before it ever gets to the computer, so the attacker can't find like a software flaw in that host firewall, exploit that, and then use that to gain on. So security groups are very, very powerful because it is basically protecting all the traffic in a network, including traffic that goes from instance to instance, even in the same subnet. And you get that level of granularity for the host firewall, but it's built into the fabric of the VPC. The entire network denies all traffic except what's allowed. All right, that's a lot. This is going to make so much more sense when we get into the hands-on. Today is just our introduction to security groups. And as simple as they are, it's important to understand that there are nuances to their implementation and there are some limitations. This is absolutely the case where doing it is better than reading about it or listening to me talk about it. And so at the end of a few labs, I think you'll really have a great understanding of why security groups are such a big deal, and they change how I design my application stacks. As a very quick review before we get into the lab, security groups combine the manageability of a network firewall with the granularity of a host firewall. They're part of the fabric of the VPC, they're always required, and there is no way around them. They are default deny, and we create rules to allow inbound and outbound traffic. But if you don't allow something, it's just denied. That's what default deny means. That's the core of it. Let's go get our hands dirty. Once again, we want to log into our test account one with administrator access. This is where we're going to really be playing with all of our networking and our creating our instances and our workloads. And then we'll need to go to VPC. Oops, I think we don't have any VPCs. Remember last week, and I told you to actually, we were going to use our CloudFormation template. So let's go over to CloudFormation. That was just a reminder to get all of that set up. Now, I have my link copied just in case you don't have yours. Remember, it was saved in your account inside of S3, and you might need that URL. I had mine on basically a cheat sheet that I always use, but here we go. I'm in S3. There's my bucket, and there's the template itself. If I click on that box and I want to copy the URL, and that should be what I need for CloudFormation. Now, just to be safe, I'm going to open the link in a new tab. We'll go to that one, and I'm going to go into CloudFormation, create stack, choose an existing template, Amazon S3. Remember, we don't need to use the builder because we already have it built and it's already sitting in our account. There's my template, and I'm going to click next. And for this, once again, for my free advertising, you all get to type in Cloud.SLA. Tell your friends, tell your family, like and subscribe. Kidding. Okay, click next. And then we're just going to scroll all the way down, click next, scroll all the way down, submit. Now it's going to start building it out, and I'm just going to pause because it'll take a minute to build out our VPC. Okay, that took about 3 minutes. Everything is created. And now I'm going to go back over, go to services and VPC. Oh, I was hoping it'd be on my short list there, so I didn't have to do the little searchy thingy. VPC. There are two places you can create security groups. You can create your security groups in VPCs or in EC2. Today, we're going to do it within VPCs because we're really trying to focus on the core of network. So let's click on security groups. You'll notice we have a security group right there, default. And Amazon is always going to create a default security group in every VPC. This is automatic. There's always a security group. Think about it. You can't deploy anything without a security group, so they always create the default. The thing is it may not have the rules we want. So let's go ahead and click on it, and let's look at the traffic. And this is where things get really interesting. This says, actually, it helps to read up here. So notice the security group ID up here, and notice the rule. So there's no name to it. It's going to have a description you'll see later that is the default. And if I slide this over, the security group rule ID is the ID of this specific rule. So this just allows us to help handle things programmatically to change rules. This says, and we're not dealing with IPv4 or v6, so this says it's going to work for all. And this says, well, let's zoom in again, all traffic on all protocols on all ports is from the same VPC is allowed to transit. So this rule, the default says anything in the same anything in the same security group is allowed to talk to the other things in the security group. Personally, I don't like that rule. That's one of the first ones that I will usually get rid of because it's just too open for me. It's almost like creating a flat network. Why? It's like a default VPC. If you don't apply a rule you don't specify a security group on a resource, it will utilize the default security group and then everything can talk to everything else. So it's just creating bad habits. Let's go ahead and create our own security group. So I'm going to show you a couple of different ways to do this. So the first is we're going to go to security groups, create security group, and let's go ahead and give it a name of, oh, let's call it database. That's going to be a good one. And then the description, and descriptions are required. So that's just one thing to keep in mind. So we'll call it database security group. And then we have to pick the VPC, which is easy because we only have one. Now you'll notice inbound rules, there's no rules, and outbound, there is already a rule. And this is a default. You don't need to keep it. But that default says all traffic, all protocols to all destinations, because that's the internet, is allowed. So this is going to allow any outbound traffic from your resource. It's okay to have this. Remember, this doesn't allow anyone to attack it from the outside necessarily. It just allows the resource itself, the instance or whatever it's going to be, that network interface, to talk outbound to the internet. Now, in a lot of cases, you might actually get rid of this rule so that it can't. Oh, and the other thing to keep in mind is, remember, it's a combination of the route table and the security group that creates the security. And in this case, if there was no route to the internet, you'd still be protected. It could just talk to the internet, the internal network. Let's not focus too much on the outbound rules for today. Let's create inbound rules. And so we called this database, and let's stick with TCP. But I could actually choose, it's just a pick list to make my life easier. And oh, let's see, does it have MySQL Aurora? Yes. So if I click that, it's going to give me a port of 3306. Now, what I could also do is just say custom protocol, and then I specify TCP, and I can specify my or all TCP, all UDP. So there's all sorts of things, or all traffic. We're going to go with custom TCP. We'll do 3306, which is a common port range for databases. Now, the source for this could be anywhere from IPv6 or the IP address of my house, and or whatever VPN I'm logged in from right now. In the source is where's it going to be? Where's that traffic originally coming from? So let's just say it's going to be 123.4.5.6. And because that's a single resource, I'm going to have to add my /32. And I could click that there. And then description would be database access. Then let's add another rule. In this case, set a custom TCP. Let's just go down. By the way, I'm going to teach you to almost never use SSH, but it makes a good example for you admins. We can actually get away with almost never using SSH. So I'm going to allow port 22 and the location that that's going to come from. So let's say that would be my app server, would be up there. Then let's just say anything SSH only from the same network. So it'd be 10.0.0.0/16. Now that's entirely too wide. Again, I wouldn't really make a good rule like that, but it just serves well for us for an example because we're going to delete this thing pretty quickly. And then that's it. So I have my two rules: database security group, my description, the VPC. Our outbound is already set. We also have our tags, create security group. And so you can see pretty clearly and cleanly how this is going to work. Oh, look, it even said, oh no, I picked the MySQL and Aurora. It even picked the SSH. Now, one of the weird things is, remember, these are the rules, and you can give the rules individual names. We didn't really do that for the rules. We gave our actual security group a name. And so that name of that security group is database, owned in my account. There's that ID. There's the description of the security group. Now, the next thing we can do is we can make another security group, and then we can actually reference between them. So let's go ahead and do that. Let's go back to security groups and create security group. And we're going to call this backup. So maybe this is where the database is sending its backup. Database sends backups. And it's going to be the same VPC. We are allowing outbound, but let's add a rule for inbound. And we're going to go with, I don't even know. I'm going to pick a random protocol. I don't know what people are using for their backups these days. Oh, let's just say NFS, Network File Server. Then the source, and this is cool. So we're going to leave it as custom. But watch when I start typing in SG dash, it's going to list out my other security groups. So now that database security group is going to be able to talk to the backup security group once I create that security group. That's all we want to do today. Set up a couple of basic rules and have an understanding of just how simple it is to define these rules. Of course, you could set your ranges up to allow any traffic from the internet or just to allow traffic from the same subnet or other subnets, but you get to see a couple of the core concepts here: the default security group rule, how to create a security group, how to create security group rules. And there really isn't much more to it than that. But in the labs, as we're coming up, I'm going to show you some of the nuances, and you're going to actually see how to leverage those in more real world circumstances with running workloads. Now, let's get rid of our VPC. If we try to do that through CloudFormation, we might run into an issue because we didn't have these specified. I didn't actually test this before the lab, so I'm going to go back into CloudFormation and I'll see if I can just wipe everything out from there. Okay, you're going to see a little editing here because I went to go delete out the VPC. I tried to do it from CloudFormation, but it wouldn't let me until I delete the security groups. I thought it might do that, and I kind of thought I was going to get away with it. I did not get away with it. This happens when I'm running live in these environments. So go into your security groups and then pick the two security groups that we created. Go to Action and Delete Security Groups. To confirm deletion, type delete below and then hit delete. And then I'll give this just a second and let's hit the refresh here. Let's hit the refresh there. Okay, it's moving a little too slow for me, so I'm going to go ahead and click that one. Action, delete security group, delete it. And we'll hit refresh there. Okay, we've gotten rid of those two security groups. The default should delete on its own, and I don't think it'll actually let me, but let's give it a shot. Delete the security group. Yeah, will not be deleted. So that's going to be there. Then I want you to go to CloudFormation and, oops, let me type that in here. And then in my case, I had already started the delete process. You hit Cloud Slaw and then you hit delete. Mine will catch up as soon as it realizes that the delete commands I put in there before, that I actually cleaned those out. So give you a little bit of a look at some of the troubleshooting here. But this should clean out relatively quickly in my environment once it retries that deletion, now that I got those security groups out of the way. Okay. Little hang up on the cleanup there. Everything else went fine. We launched our VPC. We did that with CloudFormation like we did in the last lab. So built exactly what we built before. We went in, we explored the default security group, and then we created two different security groups just to get a sense of what that process is. We're going to learn more about these as we go along. This week was just to give you a look and give you a little bit of a feel. Talk to you soon.